Okay, so question of the day 8 and lab 5 were graded and returned. I apologize for the double mailing on question of the day 8. There was a mistake in the configuration of the autograder, which was actually kind of an interesting error. Somebody asked me about it on Piazza, and I think I made the post public. I had in the autograder given a problem, a test case, and the answer, but because it returns a dictionary, the order is not guaranteed. And while most of you are using a particular type of Python, and so the ordering can sort of be expected to be the same, somebody was using a different Python, and the ordering wasn't conserved, and the printed representations were compared rather than the semantics of the expression returned. So I had to reconfigure the autograder. It took a few minutes, and that's why you got two copies of the question of the day output. It only affected a few people, 1 or 2 people. The rest of you got an extra copy. If you read the PDF that you get at the bottom, do you read that part? I mean, are you reading the stuff that comes in the feedback section? Yes or no? You really should, because there's valuable clues to where you went wrong in there. It explained the issue, and again, I apologize for cluttering your mailbox. Lab 5 was graded last night and returned. Homework 1 was posted. How many of you have started? Good. Is it interesting? Is it fun? Right? It should be fun. Who doesn't like card games, right? We'll talk about it in a minute. Reminder that it's due next Friday, a week from this Friday. So you have like a week and a half left on this. We'll talk about the homework in a minute. Midterm 1 is next Wednesday. It will be 50 minutes in class, the same procedure as last time. The one difference is that I'm actually out of town next week, Tuesday, Wednesday, and Thursday. So I won't be here for the exam. The TAs will handle the exam distribution and collection and so on. Okay, so that's next Wednesday. The midterm will cover, of course it's cumulative, but the emphasis is going to be on what we've done since the first midterm. That's why we divided it into 2 parts. We'll emphasize comprehensions. We'll emphasize for and while and simple recursion. And it may use a variety of list and string methods, most of which are on the cheat sheet. You have the cheat sheet online in Icon. So you should download the cheat sheet and study it now that you've sort of done more Python, and see what you have and what you don't have and make sure you understand what's on it. Okay, let's go through Lab 5. Are there any questions here? Is this all okay? All right, let's go through Lab 5. So the first problem is vowel count. Vowel count takes a string S and returns a dictionary of entries of the form vowel and a number, where the number is the number of occurrences of that vowel in S. The dictionary should not return 0 entries. So in other words, if you have a vowel that does not appear, then there should not be an entry that says vowel 0. So this is just a remix of question of the day 8. How many of you realize that? Right? The idiom pattern is the same. Question of the day 8 didn't go so well, so I put it on the lab to see how we did. Let's work through this just like we did question of the day 8. So the first step is read the specification carefully. Things to note here is non-zero entries, the form of the dictionary entry for every entry of a vowel and a number, right? And it tells you what the vowels are. Determine what the output structure should look like. Well, we know that it is a dictionary, and we know that this is the key value form. And then we also have to determine, we're going to do this development by stages, just like we did for question of the day 8. And the way I do that when I'm facing with comprehension is I ask myself, the first question is, what am I iterating over? And in this case, I know a comprehension makes sense because there's a hint that says use a comprehension. But aside from that, I'm building something. I'm building a new structure. This is a new dictionary, and it's being made in a very simple way. This practically reads like a mathematical expression that defines a set, right? Return a set of pairs, where the first element is one of the vowels, and the second element is how many times it occurs in this target sentence. So the output's a dictionary, and I'm iterating over the vowels. So let's do this development by stages. The first stage is decide what you're iterating over and make sure you can return a dictionary, or in this case, we're going to do a set because we're not worried about the value yet. Return a set or a dictionary with the comprehension. So here's my first step. Really simple comprehension. This basically returns a set because it's curly brackets, so it's like a dictionary comprehension, but because there's no key colon value expression, it's a set comprehension. And it's going to collect V for every V in this sequence. Notice that I don't turn this into a list, I don't turn it into a tuple, a string is a sequence. It's perfectly reasonable to iterate over a string in a comprehension. And the iterative variable, in this case the V, will take on successive sub-elements, which are simply strings themselves in a string. If I test this, it doesn't matter what I pass for S, because you'll notice S is never used in the body of the function. So it's irrelevant. I have to give you something, but it doesn't matter what it is. And I get back UIAOE, which you'll recognize as this mix of vowels, but not necessarily in the order that I added them, or that I iterated over them. Why? Because a set doesn't have ordering. It's a collection, just like a dictionary. So order is unpredictable. But we knew what was in it, so we're good. Now I'd like to extend this to add an expression so that I only iterate over keys that occur in S. By keys here, I mean the vowel, because this is essentially going to be a dictionary. So I call them keys because I know that vowel is the key of the key value pair in a dictionary. And I have to be a little bit careful here because of case. S could be upper or lower case. It doesn't say that it's all lowercase. So the obvious extension is to take this set comprehension and add a filtering expression that says only include V if it's in the lowercase version of S. So the lower makes sure that I don't lose the case information, or I don't sort of skip a vowel that only appears in uppercase. So now my same vowel count foo returns just the O, and since this only has O vowels in it, that's good. So we're halfway there. Questions? Everybody sort of comfortable with this? It's a rehash of question of day 8. So it's just good to see the stages so you sort of learn how you approach this. We talked about Polya's problem-solving steps, and this is essentially what we're doing here. We're just taking a problem and we're translating it into this algorithmic approach a little bit at a time. And that gives us an opportunity, by the way, to find bugs that we might have as we go, rather than writing this horribly complicated thing that doesn't work, and then you have to start thinking, where did I go wrong? And that's much harder. All right, so now let's move on to the value part of the expression. Remember, dictionaries have keys and values, and sets essentially only have keys. So we're going to go on and turn that set into a dictionary. So fortunately, the value part here is the number of times the vowel occurs in that sentence, in that S, in that string. And there's an appropriate string method for this. So in question of the day 8, you had to build a comprehension. The question was, how do I get a value? How do I make a list for the value that I generate once in this new structure? And the answer is, use a comprehension. But here, it's not a list value, it's an integer value, right? So we're going to see O appears 6 times. We're not going to get a list of the words it appears in, just how many times it appears in the sequence. So there's an appropriate string method here which counts how many times a vowel, something occurs. And there it is. So my original comprehension now turns into a dictionary comprehension by adding the colon and the value, which is simply count how many V's there are in S. Everything else stays the same. When I try this, I get back exactly what I expect to get back. So it looks like I'm done. But as some of you found out the hard way, when you got your answers back, you're not done because I left something out. I didn't think about corner cases. And there is a corner case here, because if I make foo uppercase, yes, I will check whether V is in the lowercase version of foo, so I will include O, right? But in fact, O is not in, O is in the lowercase, what am I saying? O is in the lowercase version of this. My problem is here that I'm not counting in the lowercase version of S. So I will include O here because V is in S dot lower, but I want, so this is wrong. I don't know where I got that from. I should be getting back O 0 here, right? Because S dot count V is going to be 0, not the empty set. So the problem with this expression is that O is in S dot lower, that's true, But when I try to count O in S, I'm going to get 0. And I'm not supposed to get 0. I'm supposed to get 2. So the correct version lowers S also in the count part. I apologize. I don't know where I got that empty list from. I just wrote this morning, so I must not be awake yet. Questions? This is straightforward from question of the day 8, I think. If you struggled with this one, and you would struggle with question of the day 8, you need to go back and start thinking about dictionary comprehensions and filters and so on, because this is important. You're going to find one of the most useful use of comprehensions is to build indexing structures. How many times does this word appear in this book? At what locations can I find the word subterfuge in a text? These kinds of things are often done with dictionaries where you build indexes so that you can find things quickly. So it's a very common idiom is to have a large amount of data, a body of data. It might be a text, it might be, it might be a book, it might be the Encyclopedia Britannica, and then pre-process the text to build a structure so you can rapidly access things that you care about. It's called an index. It's the same thing when you buy a textbook, you look in the back, it has an index and it says list comprehensions, page 97. How is that built? Well, the convenient way of building it is with a list comprehension or a dictionary comprehension somewhat like this. Okay? So this is an idiom you need to be aware of and used to. It should come very naturally. All right, let's go on. The next one, Clue AWR, takes 3 lists of words representing actors, weapons, and rooms, and returns a list of all possible Clue game solutions. I assumed people knew what Clue was, and I recognize that probably was a bad assumption on my part. Did you guys not grow up playing Clue? Right? Did you see the horrible movies? The really bad movies? I love those movies. A Clue game solution is a triple, actor, weapon, room, and the specifications we want to meet is that the 3 elements of a tuple all start with different letters. So in other words, I don't want Professor Green with a gun in the gazebo, right? They start with multiple with the same letter. I also don't want Professor Green with a gun anywhere else because the first 2 match. So, using our same incremental approach, the output is a list of tuples which constitute all combinations of the 3 sequence inputs subject to the filtering conditions. I'm going to use a list comprehension to build new output structure. It's a list of tuples. I'm going to use that comprehension. Why? I'm generating new list structure. The easy way to do it is with a comprehension in most cases, or in many cases. And besides, it says, hint, use a comprehension. So that's the first step. Now, I'm going to make this a little bit easier. Instead of trying to solve it all at once, I'm going to reduce the problem by just solving Clue with the first 2 elements. So I'm going to back a list of 2-element tuples that are actor-weapon combinations that fulfill that same condition. Now, I don't know, I must be getting old. I will soon be 65, in case you're wondering. And not only did I mess up the slide before with the empty set instead of the O0, but when I wrote the spec for this, I was editing the text and I left in an extra half line, which you probably noticed. I also was not particularly careful about implying that it was a list of lists and then using lists of tuples in the example. So I made sure the autograder didn't care. Whether it cared that you had a list, but it didn't care whether it was a list of tuples or a list of lists. And I apologize for not being specific. That's not the way specification should be written. Okay, so let's start with the 2-element. Now, fortunately for all of us, we did this in class. You may not remember, but on February 18th, the first comprehension example you saw was exactly this, a 2-element find all combinations example. You can go back and look. So the solution to this is just like it was in class. I'm going to use a list comprehension to generate new structure. I'm going to collect a list of tuples where A and W are the elements, where lowercase a is an actor in the actor list, and lowercase w is a weapon in the weapons list. And I'm going to skip the filtering conditions for starters. I just want to make sure that I get the same sort of combination stuff. And we did this the very first day I specified comprehensions. I pointed out that I can use multiple 4 elements to iterate over many things at once, right? So in a sense, what those of you who have practiced in Java, which is nested fors, these are very natural in comprehensions. So people who say to me, oh, I can't use a comprehension because I need a nested list, a nested for. You don't need nested, you can have a nested comprehension. It's very natural. And moreover, the order of these things matter. So let's just see what happens. Here's a simple example of clue. I have green and scarlet. It's scarlet with one T, right? Scarlet with two T's is Gone with the Wind. I don't know. I must be losing it. Green and scarlet, knife and gun, and I get back green with knife, green with gun, scarlet with knife, and scarlet with gun. Now notice, by the way, remember this is my signal to you that I broke the line just because I was wanting to fit on the page. Doesn't change the value of the expression, it's just a reminder for you. Notice that A in actor, it's nested exactly the way you expect. A takes on the first value in actor, which is green, and W takes on each successive value in W, which is knife and then gun. Then A takes on the second value in actor, which is scarlet, and W again takes on knife and gun, so knife and gun. So it reads just the way it unpacks this thing. Okay? Everybody okay with that? So now what's next is I want to add that filtering condition. The filtering condition is I want to get rid of green and gun, basically, because they both start with the letter G. So some of you struggled with this, but it's very straightforward. It just says if A0, because this is a string, which is a sequence type, you can index a sequence type, collect that only if A0 is not the same as W0, which is another way of saying the two first letters are different. And when I run this, I get back exactly what I want. It skips green gun because it doesn't meet the filtering condition. Everybody okay with this? All right, the extension to three cases then is exactly straightforward. The first thing you do is you collect the triple, and now you have a 4, and a 4. So you just add another 4. And it works exactly the same way. And for the filter condition, you can use this handy shorthand, which we talked about in class. What happened here? Okay. So we can test this, and we see that plum and green, gun and pipe, parlor and kitchen. I should not get plum and pipe combinations, and I don't see any there. I should not get pipe and parlor combinations, and I don't see any of them there. Oops, I messed up here. Plum and parlor. Why did I mess up there? Well, the question is, when you use this, and this is my solution is bad, I made a mistake. When you use this, are these ANDed together or ORed together? We did this in class. Remember, A equal B equal C implies that A is equal to B and B is equal to C, and therefore A is equal to C. So these are ANDed implicitly together when you chain these. You don't want to AND these together. You want to do what with them? Well, you do want to AND them together. So why is this not working? Are they ORed together? If A is not equal to W, that's true, and W is not equal to R. Oh, right. I mean, Trevor's right. We're missing A not equal to R. Good for you. So this, I thought incorrectly, was syntactic sugar for the full form, and it's not. So you do need to use the full form. I may have graded this wrong. I'll have to go back and look. I'll rerun the autograder. So this solution here is correct, the second one. The first solution is not correct, as I should have seen from my own test, because I get plum and parlor, which I don't want. Whereas here, I won't get plum and parlor. All right, sorry about that. Man, I'm not having a good day today, am I? Next one, clue. Next one, drop relative primes. So drop relative primes takes a list consisting of integers and a separate integer I and modifies L to remove any elements of L that are evenly divisible by I, and it returns the modified list. So this is really important here. The fact that it returns the modified list means what? Should we use a comprehension? No, why not? Say again? Thank you. We're not creating a new structure. We're modifying a structure that exists. When you use a comprehension, you're always creating new structure. We don't want to do that here. We want to modify what we have. And then, yeah, of course, we're going to return the list L, but the damage is done to L. In other words, whether or not you return the list to L, you want to make sure you change it. You surgically alter L. So the output is an altered version of the input. So it's a non-comprehension approach, as was just pointed out. And then there's a hint that says start at the end and work backwards. Why am I starting from the end and working backwards? Why am I suggesting you iterate from back to front here? Go ahead, Ben.
When you start removing the elements, then it shifts the indexing, and if you start with negative, then that won't happen.
Okay, so there's a couple of reasons. One, there's two approaches really. If I want to go from front to the end, from the left-hand side to the right-hand side, as Ben points out, iteration that way is problematic because the minute I remove element I and go on to element I plus 1, I will be skipping the next element. Right? Because if I remove element I plus 1 becomes element I, and then I increment my pointer, and I'm not looking at that one that was next to mine. But if I go backwards, if I remove an element, it just renumbers the ones that I've already processed, so it doesn't hurt me. Hence the hint here, the idiom is work backwards. The other way you could approach this is you could use a while loop where you get to control the iteration. You can start with I equals 0, and then while I is less than the length of your structure, or simply while I is true, you can step left to right, and if you remove an element, don't increment I. And if you don't remove an element, then you increment I. So you go through the loop, and each time I advances only if you don't remove an element. So you can shuttle along, remove an element, try it again, shuttle, so you get this kind of stutter increment. You then have to negotiate carefully the end of the while loop. So here's the answer Ben pointed out. If you delete element I and go on to element I plus 1, are you skipping an element? And the answer is yes, of course you are. So let's just do this incrementally and start by getting the iteration right. I want to start by just making sure that since I'm doing this reverse iteration, it's a little unnatural, and I want to make sure I get the limits right. So here's my first attempt. L and I are my inputs. I'm going to let J range from, and I'm going to use all of the values here, length of L minus 1. So this is the index of the last element of L, which I want to include because it's inclusive in the first step. And I want to go all the way down to element 0, but since this is not so in range, this is not included, I'm going to go one beyond 0, which is minus 1, and my decrement is minus 1. And I'm just going to write this range expression, and the only thing I'm going to do in here is I'm going to print J, the jth element, and the jth element modulo I, just to see if I got it right. So I haven't even worried about doing what I've been asked to do. I just want to get the iteration right. So I'm going to start by creating a list, range from 1 to 5. And the list for range 1 to 5 is this, 1, 2, 3, 4. And I call relative primes with that list, and the value 2 is my modulus that I'm checking. So I notice that the first value here is J, so 0, 1, 2, 3. J3 points to element 4, which is correct. And 4 modulo 2 is 0 because 4 is evenly divided by 2. Then J goes down to the third element, which is 3, to the second element, which is 3, right here. And 3 modulo 2 is 1, because 3 is not evenly divisible by 2. Then we go down to the first element, which is 2, and it's divisible by 2, and the 0th element, which is 1, which is not divisible by 2. So I can check with myself that I have the iteration done correctly. So you'll notice that I'm doing this development in my IDE, and I'm typing things, and I'm loading them, and I'm trying them, and I'm typing examples as I go. I made up this little example, and then I just called myself to see what happens. So far, so good. Normally, we would delete elements 1 and 3, so we would delete this one and this one. So let's just do that. So here's my second attempt at drop relative primes. I've just gotten rid of that print statement because I've kept everything else the same. It's right. It was right. It did the iteration correctly. And what I'm going to do is I'm going to replace the jth element with the empty list when I'm at 0, when the division yields 0 remainder. So I'm going to try it again, and I get back this weird thing here, which is not what I intended. And when I type L, I notice that L has indeed been modified. So at least I got the modification right. At least I modified L the way it was intended. So I'm closer than I think, but there's obviously something I've done wrong. The thing I've done wrong here is the following. I wanted to replace this element and this element, single elements in my list, with an empty subsequence, not with an empty list. So what I did here is I literally replaced the 2 and the 4 with an element that is an empty list. And that's what I got. Python did exactly what I asked it to do. It just asked it to do the wrong thing. The right solution replaces the slice starting at location J up to but not including the next element with the empty list. That's how you suture something out of the list. And now, when I've done that, say I have to reset my list because I messed it up. I modified it. And now when I drop relative primes, I get what I expect, and the list is the way I expect it. Everybody okay with this? So modification of list structure, don't use a comprehension. Use a for loop, use a while loop, whatever you think is appropriate. But be careful when you are playing with indices and removing things or adding things that change the length of the list or change the length of the structure. You need to make sure that your iterative structure behaves the way you think it does. Right? So I highly recommend this kind of incremental approach for a problem like this. Questions? Okay, homework 1. Few cautionary notes. First of all, you should have started yesterday. There's a lot to do in homework 1. Did you watch the video? How many of you played this game as kids? Anybody? A few of you? Okay. Every semester I have to come up with another weird game because otherwise people just take last year's solutions. And this way they can't. And if you look at the history of this class, every year is a different card game. And sometimes it's like, 13th century British card game. It's like very weird stuff. Anyway, so this one is a fairly common one. It has 11 question of the day like functions. So really, your assignment is like 11 questions of the day put together. That gives you a sense of the scope, right? You're doing a question of the day every 2 days. Now you have to do 11 of them in 10 days. So your tenor should be faster, right? You got to move this along. 2 of which are significantly more difficult than a normal question of the day. Not significantly, but they're a little bit more like lab questions. They're on the order of that last lab question. How many of you had struggled with the last lab question yesterday? So 2 of them are on order of that difficulty, all right? My advice to you is to do these in order. Start with the first one, write it, test it, make sure you have it working. I've seen Piazza posts and I've had emails from students who have started already. Good for you. I know there's at least one student who's finished the first 2. That's the kind of tenor you should be maintaining. Also, you're going to have to read and understand that big function at the end that's called play that drives the game, because you're going to have to add you're going to have to modify, you're going to have to add fix a couple of places in that code that are labeled with the fix me comment. It tells you what you need to do. And the reason it's there is because it's asking you mostly to invoke the functions you've just written, right? So if you've written the functions correctly and you fix me the stuff in the right places, invoking the functions you just wrote, then your output will match the output that I provided on the homework 1 page, which you're going to look at in a second. So there's a sample output on icon, which I forgot to post when I posted the homework, but I posted a few hours later. Please post your questions to Piazza, and please don't make them private unless there's a reason to make them private. I think people are afraid to post stuff publicly. When you post publicly, your identity is not revealed on the bulletin board. It says anonymous. I think it gives you a made-up name, Alley Cat or something says. So you have the same, you can track who people are over the postings. But you don't know who they are. I know who you are. The instructors know, but nobody else does. When you post publicly, other students can get a chance at answering the question. And sometimes answering other people's questions is the best way to learn. Ask Adi, right? He was in this class a year ago, and he spends all this time answering people's questions. You've got better Python programmer today? Absolutely. So this is how you learn as well. So I will make them public if they're private unless there's reason not to. If you're not sure, it's fine to write, I'm not sure if this can be public, and make it private. One of us will change it. Okay? Public questions benefit everyone. All right, I want to take just a little break here and look at... All right, so this is the Homework 1 handout page. And I have posted 2 traces of the game. The first trace of the game, so first thing I want to point out is that the input, the arguments to the play function are the number of players, which by the way is 1 indexed. So one of the things you have to struggle with in this problem is that there is the outward facing part of the code that interacts. Think you're writing this game for your mother or your father or your little brother. They don't start counting from 0, even though you and Python do. So I've resisted calling people player 0, even though internally they are player 0. So it's up to you to sort of add a veneer to the language that's used, that's printed out, so that player 0 is referred to as player 1, and when there are, range 4 players, they're not 0, 1, 2, 3, they're 1, 2, 3, 4. Okay, so just to be clear. And you'll notice here everything is numbered, round 1, player 1, even though internally they may well be zeros. And I don't actually think round is internally, it's just a counter. I started at 1. So how the game works is it's played in a number of turns. And a turn is where each player in the set starts by drawing a card, either from the deck or from the discard pile. And then they sort of manipulate their table. Their table is the array of cards in front of them, and they manipulate it until they can turn all the card faces up, and then they've won that round, and we add something to the scores of the players. General idea. So this is the number of players, it's 1, and this is the number of rounds. Now this notion of number of rounds is a little weird. It's actually the minimum number of rounds in a game. Why? Because when I start with a game with 4 or with 10, like they did in the video, every time we play a hand or a round, the winner gets to start the next round with 1 fewer piles of cards, 1 fewer face-down card. And as the game progresses, the rounds get actually surprisingly longer and longer rather than faster and faster because there are fewer cards to turn over. And the player who wins is the one who manages to turn over to sort of reduce their table to 0 piles. That's how the game ends, which takes at least n rounds if that player wins every round. But it can take as much as n rounds times the number of players minus the number of players, right? Because everybody could be down to the last card and then somebody gets it. So n rounds is a little misleading as a name, but it's the minimum number of rounds that you have to play. Of course, if there's only 1 player, you play exactly n rounds because only that player can win. So this is a 1-player game. And what we see here, oh, that's the volume. It's not nuts. I thought it would let me scroll. And what we see here is the first rant. This is the representation of my table. Player 1 is first to play because there's only 1 player. And what player 1 does is he draws a card from the deck, which is printed here. So I see that C2 is the card they drew. The 2 means I can play it on this pile because it has a face-down card. That's the blank. And then so I play it on location 2, and I pull out the card that's face down, and that's a B3, which I can play on location 3. I pull up the card that's face down here, that's an A4, which I can play on location 4. And then the C3 that I pull up from location 4, I can't play because location 3 is already filled. So I discard it and I print out what my table looks like. Now, the next turn, still player 1 because there's only one player, I draw a new card from the stack. It's an A7. Well, I don't have 7 locations, so I just discard it. I do it again. I get C7, which is discarded, B4, which is discarded, and finally I draw a card, C1, which fills in my array. The card that was here is turned over and must be discarded, or is discarded because the one location is already filled. And at this point, my table is filled, meaning it's all turned up cards. And so the round is complete. Player 1, of course, wins the round. And the current score is player 1 has 0 points. Why? Because the scoring is counterintuitive. I made it up. At the end of each round, the winning player gets no points. And every other player gets the sum of their face-down card values. And this accumulates round by round by round. So at the end of the day, the player who wins the last round may actually lose the game because they may have accumulated so many points in prior rounds that they still lose. Now, this card game may seem needlessly complicated. It is, and it's purposefully complicated to make you think about how it works so that you have a little bit more stuff to do. All right, so round 2. Notice how the player who won round 1 now only has 3 cards to fill. Same kind of thing happens. Finally fills them. He wins or she or they win the round again. They don't earn any points because there's no other players. Round 3, and so on. Now instead of 3, there's 2 cards. Round 4, we're down to 1 card. And so in this one-player case, when this round is complete, the winner is player 1 with a final score of 0. The minimum score wins. The only player always has the minimum score. And we've executed exactly 4 rounds because there's only one player, so nobody else can win a round, so it takes the minimum number of rounds. Is this sort of clear? Do you understand how this explains the game if you watch the video? Yes, go ahead in the back.
So you got a 1-0 there. Are you just throwing in the 1 because you want to display that player 0-1?
I have a 1, say, I can't really hear you. There's the 1-0 down here, current scores, you mean? No, that's the player number. Player number 1:0. Good question. And the reason it looks funny is because there's one player. If you have 3 players, the scores will say 1:0, 2:45, 3:17. Right? So it gives all the scores. And you also notice that when the player plays, it also shows you their score here. But here at the end of the game, of the round, it'll show everybody's score. Because remember, the player who ends the round, their score doesn't change, but everybody else's does. Any other questions? Yes?
Where you have the cards, when they say like, C1, B2, A4, are those just for the separating of the suits?
So the drawing B2 from deck?
Yeah, like
Okay,
like
so
they're different.
so I think your question is B2 the suit and the card value? And the answer is yes. So in a regular deck, you have 13 card values and 4 suits. And you'll notice that in the signature of the default deck creation function, I've provided you the codes for getting the hearts and diamonds and so on, which is kind of cute. The problem is that here, we're writing the game, we've abstracted the game from 2 players to anywhere from 1 to any number of players. And 52 cards don't last very long if you have more than 1 player. So what I've done to extend the game is I've made the size of the deck dependent on how many players. And this is all handled in that game driver thing, but basically if you have 2 players, then you have 4 suits. If you have 3 players, it goes to 5 and 6 and 7 and so on. And obviously I run out of suits after 4. So I'm just using the capital letters A through Z as suits. All right, so if I need 6 suits, it'll be A, B, C, D, E, F. Okay? If I need 11, I'm going to go up to H or whatever it is. So if you were playing with the canonical regular deck, you would see discarding club 2. Okay? Good question. All right, we good with this? Can we go? Yes.
When we're doing print statements, like for example, when it says round 4, and there's a space, and there's the next one, can I do like 3 different print statements?
Oh, for these? So actually, you do very few of these. If you read the game driver function, I think the print statements are all already there. What happens is that some of those question of the day like functions you have to write, they don't actually print anything, but they return the string, they construct the string that will be printed. So if there's a thing called show table, it's supposed to return a string that when printed is that representation. So I don't think this comes up. If it does, you're free to configure the print statement as you prefer. But I don't believe that comes up in the template. We can check in a minute. Okay, anybody else? All right, let's quickly go through this game where we have 2 players, just so you can see how it worked now that we've seen the simple case with the 2-player case. So the same thing applies. I have 4 starting table elements, so the minimum number of rounds is 4. I believe this game runs for 7 rounds. All right? And the first player to start is generated at random. So we don't always start with player 0. Here we're starting with player 1, which is printed out as player 2. Round 1, player 2 to play, 0 score, draws B7 from deck and discards it. Now player 1 to play, draws D7 and discards it, player 2. So we have to handle the incrementing of the player number modulo the number of players to get turns, in increasing order. So all of this is pretty good. Here we get player 2 plays and finally draws something they can use. So they pick up a C2, which gets played in the second thing. The C2 is played on location 2. That contained the C4, which is played on location 4. And then that card, hidden card there, was a B4, which is discarded because the 4th lot is already filled. And what I want you to notice here that's important is, at this point, it's player 1's turn, and instead of drawing a card from the deck, or sometimes called the draw or the stack, but it's just the leftover cards in the deck, most of the time you draw from the deck, but here, there's an opportunity to pick up a card that's valuable. He doesn't have anything on its 4th location. So drawing B4 from the discard pile lets me immediately play the B4, which then gives me the B1, which I play, and then I discard the B6. So I show you this because I have 4 piles in my table, 4 hidden cards. That means only cards with values 1, 2, 3, and 4 work. Cards with values 5, 6, and 7 are never good. And most of the time, the discard pile will have all those crappy cards. There's like Jack, Queen, King, right? They're not useful. But sometimes, when your opponent has already filled their slot and they get another one, that card can be useful to you, and you should always pick a card from the discard if you can use it. So this is a decision that your system has to make, and it's discussed in the handout. So I just wanted to point out the discard stuff. Once that's done, let's see, the round sort of proceeds as normal. You can see it's taken a while to get to the end. And finally, player 1 manages to fill their table. They discard A2. Round 1 complete. Player 1 wins the round. And here for the back, notice the scores as 1 still has 0 points, but 2 now has 4 points. And the only reason I can surmise that 2 has 4 points is that whatever card is still hidden on their table here is a 4-point card. So that you get the sum of all the hidden cards. Now notice, in the next round, player 1 only has 3 down cards, but player 2 still has 4. All right, so the game continues as before. In the second round, player 2 wins the round. Now they're both playing, and player 1 scores 2 points or gets 2 points. In the third round, everybody has 3 cards. Player 1 wins the third round, so now 2 has 13 points, and so on and so forth. So round 4, round 5, round 6. Okay, it took 6 rounds. In round 6, player 2 only has 1 card on one stack on their table, 1 card on their table. Player 1 has 2, and player 2 is and player 1 has the unfortunate. So player 1 draws a card and nothing happens because it's a 3. Player 2 has the good fortune of drawing a C1 from here and ending the round. And the current score is player 1 has 20 points, player 2 has 13, and player 2